Hey everybody, and welcome to 4.1. Today I'm coming to you from my basement because I am quarantined at home like probably many of you due to the corona COVID-19 virus. So I hope that this video finds you well and that you're doing okay at home with your virtual learning. Um, Today we're going to be discussing graphing linear equations. And for our learning target, I can understand that lines represent solutions or answers of linear equations, right? Kind of a lot of, it's kind of wordy at first here, but in chapter 4 here, we're going to be doing a lot of graphing, and there are a lot of different ways to graph. And I'm going to show you a bunch of different ways to be able to graph. Don't feel like one way is better. You might prefer one way to another, but I think you'll see in the end of this chapter that there's a lot of different ways to be able to graph. So for this first section, we're going to be using a table of values when we're graphing. For our key idea today, it says a linear equation is an equation whose graph is a line. And that makes sense. A linear equation, the root word of linear is line. So it's an equation that when you graph it, it makes a line. And the points on the line are solutions or answers that make the equation true. You can use a graph to show the solutions of a linear equation. The graph below, right here, represents the equation y equals x plus 1. So here's an equation. Remember, an equation has an equal sign in it. Y equals x plus 1. And when you graph that, this is what it looks like. And how do you go from a math equation like this to a line? How do you get there? Well, that's what we're going to be talking about today. And what we're going to use today is a table of values, just like you see here. Okay. So let's try one. It says graphing a linear equation. Graph y equals negative 2x plus 1. So the first step in doing that is to make a table of values. And there's lots of different ways to do this. I'm going to show you a t-chart in just a second. But the first one, I'll show you how the book teaches it. And they both work. They're the same thing, essentially. I just think a t-chart is a little bit simpler. But let's make a big table of values here. So first, I'm going to start with my x values. Next, I will put in my equation that I'm working with. So my equation is y equals negative 2x plus 1. Okay. Next will be my y value that I get when I enter that. And lastly will be my ordered pair. You can think about this as x comma y. Same thing. All right. One of the hardest things I think students have difficulty with is selecting their x values. And when you select x values, I'm going to give you one piece of advice. Keep it simple. Okay? You can choose, and I'd write this down, choose any x value, but keep it simple. All right? So the ones that I usually like to choose are like 0, 1, 2, and 3. Sometimes it could be helpful to have a negative in there as well. So I'll choose negative 1, 0, positive 1, and 2. These are simple, easy numbers that I can very easily substitute into my equation here of y equals negative 2x plus 1. Again, it doesn't matter what x you choose. You can pick any number, but I like to keep it simple. All right, for my first x value in this column here, all I need to do is insert -1 for x. The correct term is substitute. -2, I'll substitute in -1 for my x plus 1. Okay, that's going to be the same method for each one of these. Substitute in what I know my value of x is. Here it's 0. Y equals -2 times x is now 1 plus 1. And lastly, y equals -2 times 2 plus 1. Okay, once I have my different x values substituted in for x, now I can find out the answer, y. So y equals -2 times -1 would be +2. +2 plus 1 would give me 3. Okay, so when x is -1, y equals 3. So that would be my ordered pair, -1, 3. Let's do it for a different value of x. -2 times 0 is 0, plus 1 is 1. So this ordered pair would be when x is 0, y is 1. When x is 1, -2 times 1 is -2, plus 1 is -1. So my ordered pair would be 1, -1. And lastly, when y is 2, -2 times +2 would be -4, plus 1 is -3. So 2, -3. Right. There I have my ordered pairs for step 2. Now I plot those ordered pairs. Step 2, plot ordered pairs. Okay, so I need to make a graph. If I'm looking at my numbers here in my graph for my x values and my y values, they're all relatively pretty small, so I don't need to worry too much about going by anything other than 1. So here is my y-axis, and here is my x-axis. My first ordered pair is -1, 3, so that would be left 1 and up 3. Work with me here, dots. My next ordered pair is, I might just do an open circle, that way it doesn't erase. 0, 1, so over 0, up 1. My next is 1, -1, so right 1, down 1. And then lastly, I have 2, -3, so right 2, down 3. And you can see that these 3 points are going to make a nice line. So the third step, step 3, is to draw a line through the points. Okay, draw a line through the points, and then I'm done. So as best as I can here, not promising a perfectly straight line here, but if you have like a textbook or something, you can, or a ruler or something like that. Sorry, my line is off a little bit. I wonder if I can move that, if that would work. Oh boy, this could be interesting. Come on, slide over. No, it's not going to work. But hopefully, maybe did move. Oh, not move too far. Hopefully you get the idea there that I would just connect my dots with a straight line. Okay, and that's how I would graph this equation, y equals -2x plus 1, using a table of values. All right. There are other situations where, for our next key idea, you might have a perfectly horizontal line, like in this case right here, or a perfectly vertical line, like in this case right here. And I think in the next example, you'll see that. Yep, here it is. Okay, so graphing a horizontal line and a vertical line. So let's first start off by making our y-axis. Ooh, that's not a straight line at all. Our y-axis and our x-axis. Sorry about not being able to draw straight lines, guys. This is tough. And for the first one, it wants me to graph y equals -3. Anytime you have a case where it says y equals, that's going to be a horizontal line. And anytime you have an equation that says x equals a number, that's just going to be a vertical line. Notice that these equations just have one variable. So it's like x equals a number, like 1. There is no y here. And the same for this case, there's no x. It just has one variable. So that's why it's not like this example here. There's not two variables. It's just one. So to graph y equals -3, you'd go to where -3 is on the y-axis. So here's my y-axis, down 1, down 2, down 3. Okay, that's y equals -3. And then it's a horizontal line at that point. So a horizontal line at y equals -3. I know that might seem counterintuitive because since it says y equals, you're thinking that it has to deal with the y-axis, which is a vertical axis. But this is at the point where y is equal to -3 on the y-axis, and then it's a horizontal line. Just like shown here, it's a horizontal line. And in the other case where you have x equals 2, let's draw ourselves our x and y axis again. You'd go to where x is equal to 2. So here's our x-axis, 1, 2. There's the point. And you draw a vertical line at x equals 2, similar to what they did here. Okay? So you might encounter those types of problems where you have just a horizontal or vertical line with one variable. Okay? All right. For the on your own section, there are 4 different examples here. And then it says use a graphing calculator to check your answer. So I did provide 2 graphs for you here. You might want to think about trying to squeeze, if you can, a couple of graphs on one sheet of paper if that's possible. Okay, so go ahead and pause the video now to see if you can graph these 4. All right, so I'm going to show you how to do a T-chart for the first ones here. Okay, so I know before when we made our table of values, it was rather large. I'm going to show you how you can just do it with what's called a T-chart. So X and Y. So again, I'm going to pick simple values. So I'm going to pick -1. I'm going to pick 0. I'm going to pick 1. And I'm going to pick 2. When X is -1, what is my Y? Well, 3 times -1 is -3. And there you can see this will be my point. -1, -3 for my first point. When X is 0, 3 times 0 is 0. So 0, 0 is another point. When X is 1, 3 times 1 is 3. And then lastly, when X is 2, 3 times 2 would give me 6. I'm going to split this in half here. And then I'm going to make This is going to be my y, and this is going to be my x for number 1. Okay, so the point -1, -3 would be -1, -1, 2, 3. The point 0, 0 would be right here. 1, 3, 1, up 1, 2, 3 would be right here. So you can see that my line is going to look like that. Okay. Now, it says use a graphing calculator to check your graph if possible. You don't be afraid to go to Desmos and double check that. Remember, Desmos is you can start graphing, and you can use a graphing calculator to double check. So you could plug in y equals 3x. And you can see it automatically graphs it for you. If you want to zoom in, you can zoom in. But it goes through the point, the same points that we had. 0, 0, 1, 3, 2, 6, and -1, -3. So that's a kind of one way that you can double check your answers is going to Desmos. Okay. Number 2 was -1/2 x plus 2. All right, I'm going to continue with my t-chart here. And I'm going to do, I'll just do 0, -1, and 1. 1/2 times 0 is 0. -1/2 times 0 is 0. Plus 2 is 2. -1/2 times -1 would be +1/2. +1/2 plus 2 would be 2.5. And lastly, 1 -1/2 times 1 would be -1/2. And -1/2 plus 2 would be 1.5. So let's see if we can't graph that here. 0, 2, so over 0, up 2. -1 is 2.5, so up 1, 2.5. Right there, it's halfway. And then 1, 1.5, up 1.5. You can see our line is going like this. Okay. Hopefully that makes a little sense. Again, you can enter this into Desmos if you want to double check. For numbers 3 and 4, those are those vertical and horizontal line examples that we saw in example number 2. So I'm going to make 2 graphs here for you. I'll do number 3 right here and number 4 right there. And the first example is x equals -4. So I will go to where x is equal to -4 on my horizontal axis here. 1, 2, 3, 4. I might want to extend my line. And remember, that's a vertical line where x is equal to -4 is a vertical line. And then for number 4, where I have y equals -1.5, I'd go down 1.5 of the way here, and that would be a horizontal line at y equals -1.5. All right. If you have questions on those, please let me know. We have one example left to go through here, and that's the real life example. Okay, I'll be back in just a sec. Okay, in the real life application, it says the wind speed, y, in miles per hour of a tropical storm is y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. It wants us to graph the information first and then find out when a tropical storm becomes a hurricane. Okay, so in the context of this problem, X is talking about our hours after a storm enters the Gulf. So I'm going to make an XY chart here. And here is the equation I'm going to be using. And again, I'm going to pick easy numbers. So I'll start with 0, and then I'll plug in 1, 2, and 3. I wouldn't choose a negative situation here because we're talking about hours, and we don't have negative hours. So for 0, 2 times 0 is 0, plus 66 is 66. So I forgot to put my y there. For 1, 2 times 1 is 2, plus 66 is 68. Whoops. Sorry, my computer just... I don't know if I hit the wrong button or what. 2 hours, 2 times 2 is 4, plus 66 is 70. And 3 times 2 is 6. 6 plus 66 is 72. And then I can graph these ordered pairs. So you might say, well, how am I going to graph 66 as a y-coordinate? I'm definitely not going to go by ones. Well, I'm going to show you kind of another trick that you can do. Since I'm not dealing with any negative numbers, I'm just going to graph the first quadrant, like so. So all my numbers are positive, so I'll just graph it here in the first quadrant. I'm not going to worry about 2, 3, or 4. And my x, I was talking about hours, and 0, 1, 2, 3, 4, 5, 6, and so on. And what I can do is notice that my numbers on my y are actually pretty close together. Like I could go by ones and graph that pretty easily, or even by twos. But I don't want to start at 2. I don't want to start at 1 and go all the way up to 60. So what I'm going to do is I'm going to enter in what's called a break in my graph. And what that means is that I'm just skipping 1 through, let's call it 59, and let's start with 60. And let's go by twos. So 62, 64, 66, 68, 70, 72, 74, 76, and so on. So I'm going by twos, and I just put a break in my graph so I can skip the beginning numbers. And then I'm going to graph my points, 0, 66. So in 0 hours, it's 66, and I'm talking about miles per hour here. I can label that. So wind speeds in miles per hour. And then my next point after 1 hour, it's 68. And you can see the relationship here. I'm increasing by 2 each time. As 1 hour goes by, I increase my miles per hour by 2. So 2 hours would be 70. 3 hours would be 72. And then I'll make my line here. And there is the graph of that situation. Letter B then asks, when does the storm become a hurricane? Well, let's reference our diagram over here. It says a tropical storm becomes a hurricane when wind speeds are at least 74 miles per hour. So let's look at our graph and see after how long are my wind speeds 74 miles an hour. Okay, I'm going to follow 74 miles an hour over until I get to my line that I made. Remember, the points on my line are solutions or answers. And if I follow that down, how long is that? Well, that would be after 4 hours. So when does the storm become a hurricane? The storm becomes a hurricane 4 hours after it enters the Gulf. 4 hours after it enters the Gulf of Mexico. Okay. Lastly, please pause the video here for the last on your own. All right, it says, what if the wind speed is y equals 1.5x plus 62? When does the storm become a hurricane? Hopefully you had a chance to graph that. I'm not going to graph it just for time's sake here, but you should come up with 8 hours after it enters the Gulf of Mexico. All right, that finishes up 4.1 with graphing linear equations. If you have any more questions, please be sure to let me know. I'll see you next time.